Okay, good evening, everybody. So let us start. I hope my voice is audible to all properly.
Yes, sir.
Okay. So my screen is visible to all, full screen.
Yes, sir.
Okay, great. So today we are covering the final part of this workshop, that is the image processing. Though here we will just discuss regarding how we can actually modify or modify the images, changes the color, but actually image processing has lots and lots of applications. We will be discussing in our PPT in the presentations, and we'll see how it happens. So what is image processing? So image processing is very simple thing, that how we can manipulate the image. Okay, a method to perform operations on an image to enhance or extract information. So image processing is a method used to perform operations on an image to enhance it or extract useful information. That is the important point. That is, extract useful information. It is a type of signal processing where the input is a image such as photograph or video frame, and the output can be an image or characteristics features associated with the image. So you have this image acquisition in the picture you can see. Then digitization, or how you can make it like digital for our world. Enhancement, segmentation is actually like you will need to break the image into small parts. Then you can next is feature selection, how you can extract the features from each and every component. And then image representation on interpretation. So this is a classic step how you can how it is done. But the thing is that this is one of the things like which has the maximum application, and particularly in this medical field, you may see that there are so many applications coming up. To give you important applications, there are several PhD studies or research studies which is happening, like how you can use the image, that is MRI image, and you can tell that the person is suffering from any neurological disorder, or if you are getting any cell count, how you can tell that the particular colony can represent a disease. Or even in the field of agricultures, like by just seeing the image you can tell that the plant is diseased or not. So image processing is a important part, like wherein you can do lots and lots of applications. Actually, there are, you may get several research papers saying that disease recognition or disease detection using image processing. So just with the images, you can understand that if it is the person is diseased or not. Other day, Anusha, you had asked me like how you can extract the information from a handwriting. Actually, you can
Yes,
even
sir.
use the first step is image processing. Sometimes you will be getting some handwriting which is like it is not possible to understand the handwriting. You can apply the first the image processing, and you can get the clear handwriting. Then you can use it. It has like in the medical records and all, you can use it. So just with the I was telling in the even in the last class, just digitizing the handwritten handwritten wordings or letters or numbers. So first step, it can be like image processing, just to extract the features, breaking the components, and go ahead. So image recognition is having a very, very important task. There are so many research papers available just with the image processing. Yeah, OpenCV, this is a very, very, I won't say very important, but it is one of the most widely used open source software. That is open source computer vision library. So it is in OpenCV, often referred to as CV2. The module name in Python is an open source computer vision and machine learning software. Several of the application image learning processes works with this OpenCV or CV2. And sometimes even in there is even in a C programming, I think C++, there is OpenCV is used. In Python, you are using a CV or CV2. So you have to check it out, because this is, application is there even in C, even in our Python. So developed by Intel and now supported by Willow Garg, and it's the OpenCV provides a comprehensive suite of tools for real-time computer vision applications. It is widely used, and above all, it is free. OpenCV has its own tutorial. So advantages of using OpenCV, that is, it is the first, it is open source, that is freely available under the BSD license, making it accessible for both academic and the commercial use. Offers a wide variety of functionalities covering most aspects of computer vision and image processing. cross-platform. It runs on multiple platforms like Windows, Linux, Mac OS, and all. I think in the last classes somebody was asking. I don't remember who was asking that. Is Python available for both Windows and Linux? Though actually the answer is yes, and in Linux, Python is inbuilt. But there are some packages of Linux. You have to check it out that all the packages are not for Windows and all the packages are not for Linux. Even some of the packages may not support in Google Colab. Even some of the packages you need not to install in the Google packages. That you have to be, when you are doing the higher works, you will come to know. So there are several packages which are platform specific. Some packages are what you call Windows, that is operating OS specific. That you have to understand it. Even it is same for R, even it is same for Python. Okay, so remember, but usually, like if at all you are using Google Colab, so the particular software, it will that Google Colab will not have any difference if at all you are using Python or Windows or Linux. That is one advantage of using Google Colab. So like all the softwares which are supported in Linux, you can use it. This one thing you can that is the best advantages, but the even the collab has its own disadvantage. So then it becomes a problem. So that is what you need to, when you are going the higher works, you will understand. One moment. So these are now you need to understand. So when you are using the or working with the different various packages. Okay. So optimize performance, optimize for the real-time application, taking advantage of the hardware accelerations wherever it is available, and large community and support. Yeah, so OpenCV has its own community and it is very large. As I told that it is used in the medical field. You maximum, I find that has wide application in the medical field. So even as I told, OpenCV has its own documentations, tutorials, and it has a very large community of the developers and the researchers. Features, key features and the capabilities. So image processing, filtering, it applies various filters like Gaussian, median, bilateral to smooth and sharpen the images. Transform, perform geometric transformations like scaling, rotations, translation, and affinity transform. Color space conversion. It converts images between the different color spaces, right? RGB to grayscale, HSV, lab, etc. Image threshold, a technique like binary adaptive and OTU thresholding to segment images based on the intensity values. And then you have feature detection and extraction, that is edge detection. So algorithms like Canny, Sobel, SCAR to detect the edges in the images. Corner method like Harris corner detection and good features to track. Key point detection and description algorithm like SIFT, SURF, ORB for detecting and describing the key points in the images. Template matching, most parts of an image that match a template image. And then you have object detection and recognition, face detection, hard cassettes and deep learning based methods for detecting the faces in the images and videos. Object tracking techniques like mean shift, cam shift, and more advanced methods are used in deep learning. Recognitions, algorithms for the object and pattern recognitions use feature mapping and machine learning. You might be wondering that you might have seen this face detections or biometric and all. Most of them can use this OpenCV, but there is one thing is that it will be embedded with an IoT. So what is IoT? Internet of Things. So that the particular software, it will be connected with an instrument. So that also your OpenCV supports, so that you can the image can be extracted with the help of any camera, and it can be processed by your CV2 library. Okay, and there are so many you can see research papers like wherein image processing as well as the with a particular device. So that is also an advantage of OpenCV, and Python has its own advantages. Okay, Python can be also used, or Python has applications in IoTs. That also you can understand or remember it. I think in the first class I had discussed bit of IoT. So in IoT you have Raspberry Pi, which actually uses Python for its own work. So in IoT, what happens? The programming will be there, but you will not get any output directly in the your system. That is your computer. That is in Colab or any other platform you are using, but it will be used for activating the device. So that things that is one, and even one more applications for Python. It can be that is, it is used in electronics. Okay. Then video analysis, like motion detections, technique to detect and analyze the motions in the video streams, optical flow methods to compute the motion of object within the consecutive frames. Then algorithm segment moving objects from a static background in the videos. Then you have 3D reconstruction, that is stereo vision, techniques to extract depth information from the stereo image pillars. Then structure from motion, reconstruct 3D structure from the multiple images taken from different viewpoints. Then you have within the machine learning application, you have like classification, built-in learning algorithm like SVM, KNN, decision tree, etc. for classification tasks, training and testing, tools to train and test models with various data sets, and then deep learning integration, that is support for the deep learning frameworks. You can actually use the image processing techniques in the TensorFlow, that is in the deep learning, and Caffe for the advanced neural network applications. Before moving forward, I can tell you about one very good book. It is completely on this one image processing. Not this, not this. This one. The PDF is available. So this one I am sharing in the chat box. So you can have a look. This book contains very useful things. Most it is on image processing. There are so many image processing techniques with deep learning. Okay. So I have shared a book in the chat box. You can have a look. Okay, so one of the first steps in image processing is RGB to BGR. So you are thinking, what is this RGB? RGB stands for red, green, blue. BGR stands for blue, green, red. Just reverse. So sometimes you need to reverse the color combination, that you can do it. So it depends, because as I told, in image processing there are several things. So it depends on what you need it, and based on that you can process it. There are complete documentations available for all the techniques. So RGB color model is a common color space used for the representing images. However, many image processing libraries such as OpenCV use a BGR color model instead. Therefore, it is often necessary to convert from RGB to BGR and vice versa. Why? Because why you need to convert? Because it depends again on your work. So, what is your project? And like you need to have you need to process a color image, or you need to process a black and white image, or you need to detect the edges wherein you need a sharper image. So it depends. So that is why you need to convert the colors. So you can just reverse the colors and you can extract the information. So why convert to RGB to BGR? So OpenCV, a popular image processing library, uses BGR by default. Converting image to the BGR ensures compatibility when using OpenCV functions. Yes, that is the thing why you need to convert. So standardization, different libraries and devices may use different color format. That is the main thing is that. So what exactly you are looking for? So you want RGB color only. If a image you are getting is of different color, so you need so what color you need for your output. So based on that you can convert. So converting between RGB and BGR helps standardize the format for the consistent processing and analysis. Okay. So don't think that just we are changing the color for our own vision. Nothing like vision. It is depends on what exactly we need or we are looking for. So conversion method. OpenCV provides straightforward method for the convert color between color spaces using the CVT color function. So manual swapping directly swap the channels in the image array to convert from the RGB to BGR and vice versa. So converting between RGB and BGR color space is a common task in the image processing, especially when working with the libraries like OpenCV that uses BGR by default. Understanding how to perform these conversions, both using built-in function and manual channel swapping, ensures compatibility and correctness in the image processing workflows. Okay, then you have this grayscale. So sometimes, you for your particular work, you cannot detect using the colors. You need to convert into grayscale. So you can also convert it into the image into completely gray. So grayscale is the range of the shades of gray without apparent color. The darkest possible shade is black, which is the total absence of transmitted or reflected light. The lightest possible shade is the white, which is the total transmission or reflection of the light at all visible wavelength. In image processing, a grayscale image is one where the value of the each pixel carries only intensity information. Characteristics: single channel. Unlike the RGB images that have color channels, grayscale images have only one channel representing intensity, and the pixel values ranges from 0 to 255 for the 8-bit images, where 0 represents the black and 255 represents the white. Intermediate values represent varying shades of gray. Okay. So these are your grayscale converted grayscale. Okay. Okay, why use grayscale? For simplification, it reduces the complexity of the image data, making it easier and faster to process. Focuses on the structure, it eliminates the color information, which can be used for analyzing the shape, texture, or structure of the object in the image. And memory efficient. Actually, the grayscale, it requires less memory when compared to the colors. So that is again an advantage. And converting to grayscale, to convert the color image to the grayscale, the color information needs to be compatible into a single intensity value. This is typically done using the following formula, which is the weight sum of the RGB components. So you have a formula given in the below, you can take it. The weights corresponding to the human size sensitivity to different colors, giving more importance to green and less to the blue. So applications of the grayscale images, often used as pre-processing step for the other image processing, such as edge detection, threshold, and segmentation. Pattern recognition simplify the task of recognizing the pattern, shape, and object by focusing on the intensity variations rather than the color. And many of my students project, they have converted it into the grayscale for their processing. So medical images, commonly it is being converted into the grayscale for the processing. Commonly used in, okay, there is a question. Okay, edge detection. Okay, I will tell you. Edge detection is you need to detect on the side edges, corners, and all, so that you can understand if there is any particular particular features in the edges. Okay, commonly used in the medical image modalities such as X-rays, MRIs, and CT scans, where the color is not necessarily for the diagnosis. You might have wondered why your X-ray films or MRIs are in the grayscale. Okay, in the medical diagnosis, because it is easy to process the grayscale. Initially, all the photo films, if you remember, initially all were the grayscale. Now only we have the colors and all. Now the negatives are only not available. Initially, everything was grayscale, because it is very easy to process an image using the grayscale. And the edge detection. Edge detection also becomes very easy in the grayscale rather than the color. So that is a very important application for the grayscales. So grayscale images are simplified representation of the visual data that only contains intensity information. This reduction in the complexity makes them easier and faster to process. Is a fundamental step in many image processing workflows, especially where the color information is not critical for analysis. Next is ROI. ROI stands for the region of interest, and it is mainly used in the medical image processing. Okay, especially you will find this ROI in MRI in images for detecting any like schizophrenia or Alzheimer's or etc. etc. Any neurological disorder, because the MRI images you get only for the brain pictures. So their ROI plays a great role. Why means you can understand that the person is suffering from Alzheimer's or Parkinsonism or schizophrenia, or a common term like any neurological disorder like dementia, with the help of this ROI. Usually, I told usually it is used in medical. Maybe also it can be used for the other subjects which I am not aware of. But yes, because many of my students, they have processed the this one ROI, where they detected the ROI in the for detecting the brain diseases like schizophrenia or Alzheimer's and so on. Okay. In medical image processing, the region of interest is a specific area within the image that is of particular interest for the analysis and diagnosis. Focusing on the ROI allows for more detailed examination and processing, enabling clinicians and researchers to extract relevant information, enhance diagnostic accuracy, and improve treatment planning. And one more thing, the ROI, it can be like, in this particular, it is like complete MRI, but you can actually, the ROI can focus to any particular area. Okay, and then it can be highlighted in a red color or green color. It depends on that. So focused area targeting the ROI allows for concentrating on the most critical areas such as tumors, lesions, etc., or other anomalies, reducing the amount of data to be processed and enhancing the computational enhanceability. So actually, just I can say that here it is. This is your ROI. Suppose this can be your ROI. So you can just take this part and you can enhance this picture. So you can say you can save your processing like computational what is speed and other features. So just you can pinpoint this, you can enhance this only particular region, and you can do your work. So that is why ROI becomes very important. Improved accuracy. By isolating the ROI, clinicians can perform more precise measurements and analysis, leading to the better diagnostic accuracy and more reliable outcomes. Enhanced visualization. ROI extraction can help in enhancing the visualization of the specific areas, making it easier to identify and characterize the abnormalities. Then you have quantitative analysis, enables quantitative analysis of the specific region, such as calculating the size, shape, texture of the tumor, which is crucial for treatment planning and monitoring disease progression. One moment. No. Techniques for identifying and processing the ROI. So manual segmentations, clinicians manually outline the ROI based on the expertise and visual inspections. While accurate, this method can be time consuming and subject to inter-observer variability. Then you have this automatic segmentation. Algorithms and machine learning models are used to automatically identify and segment the ROIs. Common techniques include the thresholding, that is, identify the region based on the intensity values. Edge detection detects the boundaries of the ROI using the gradients. Region glowing, segment the regions based on the similar criteria. Then using clustering, group pixels into the cluster representing the different regions. And then in deep learning, it uses CNN for automated and accurate segmentation of the complex structures. And then hybrid method combines manual and automatic methods, where initial automated segmentation refined by the human experts for the improved accuracy. So whenever you are doing an image processing, especially in the medical areas, you need to know what is the ROI. So any research paper will tell in the related areas will tell you what is the ROI and where is the ROI. So then it becomes easy for you to go ahead with the research paper. Okay. So remember this very important point. Okay, applications in medical imaging. So in oncology, there is a cancer, definitely. Identifying the measuring the tumors in the MRI, CT, or PET scans, ROI analysis helps in monitoring the tumor growth, assessing the treatment or response, and planning surgical interventions. Cardiology, analyzing the specific regions in the heart in the echocardiograms or MRI scan to assess the cardiac functions, detect abnormalities, and plan interventions, neurology, studying the brain regions in the MRI or CT scan to identify the lesions, monitor neurological disorders, and guide neurosurgical processes. Orthopedics focus on the joints, bone region in the X-rays, MRIs to diagnose the fractures, assess the joint degeneration, and plan the orthopedic surgeries. And in ophthalmology, analyze the specific areas in the retina, fundus image to detect and monitor the eye disease like diabetic retinopathy and muscular degeneration. Okay, so an example workflow for the ROI in the medical image processing. Okay, so you have this image. First, you need to acquire the image. So from where you are getting the, so we have to be very careful in this particular area for because these are all medical images and all will be copyrighted. Even the free images may be available, but if at all it is for your PhD work or some other, then check it out that properly cite the images. Okay, from where you are taking it, because not 99, 100% of the images are copyrighted, but definitely you can use it as I told, and you can cite it, give a proper citation. And above all, it is actually easy to get the images from many sources. Okay. So image acquisition, obtain high quality medical images using the modalities like MRI, CT, X-rays, ultrasound, etc. Pre-processing enhance the image quality by noise reduction, contrast enhancement and normalization, ROI identification, use of manual, automatic or hybrid method to identify and segment the ROI. And first of all, ROI identification, it is based on the research papers. So don't think that I am an expert in the ROI and can do it. It is always good to study the research papers before detecting the ROI. Okay, and always it is understood that you can consult any doctor or any clinicians and go, and then if it is a new image, it is better to consult a doctor or clinicians before going ahead with the ROI detection. Okay, that is because that is the thing which gives you a proper conclusion. Then feature extraction. Sir, where exactly noise reduction comes in the picture? Yeah. See, it can come anywhere in the picture. Wherever, first of all, if it is a blur, and if there are, you feel that there are more colors are there in a particular area, you can reduce the noise. And specifically, if there is a noise in your ROI, then it becomes very problematic. You need to remove the noise. So noise means in this image, it is like extra colors. So that has to be removed, extra colors usually. Okay. Okay, feature extraction, extract relevant features from the ROI, such as shape, texture, and intensity. Then analysis and interpretation. Perform quantitative and qualitative analysis of the ROI to derive diagnostic information, and then visualization and reporting. Visualize the ROI and present the findings in a clear and concise report for the clinical use. So image process, I won't say image processing, rather if it is a disease detection, your conclusion should be ROI. Okay, that you have to understand it. Do not give a simple image processed report and you cannot detect a disease. In the disease detection, the first few steps will be that, yeah, that is the conversion and all RGB to BGR and all grayscale, etc., etc. Maybe to remove the blur, maybe to sharpen, rotate, and all. That and all you can do it, but specifically for this one, medical images, without ROI, your research paper will not get accepted. Anyway, you are not detecting the disease. So it is given here in the flowchart. So SAR image after threshold segmentation, morphological operation, opening and closing upper divide into the connected regions and all. Then finally you have extract ROI. That is the important step. Important and the main step. Okay, key concept in the image processing, image acquisition, pre-processing, image enhancement, image restoration, color image processing, image segmentation, feature extraction, image compression, and image restructure. This is all for pre-processing. For disease reduction, last you have to include a region of identification of ROI. Just remember it. So for image acquisition, you can use several like cameras, scanners. You might have you seen that in the wet lab, your friends might be taking using the camera to take the pictures of the colonies, bacteria counts, etc., etc. You can actually take those images and you can publish a separate paper. You just using one image. Think it out on that. In bioinformatics, we have lots and lots of scope. Take one image of your wet lab. As you can see, that many of your friends are using a camera. They are fitting on the microscope and they are taking the images, large images of a bacterial count. If it is a diseased bacteria, or for usually diseased bacteria, you may not find it in your lab, but plant diseases, yes. And you can actually write a proper research papers. Okay, just you can think on all these things, how you can utilize in a wet lab or a biotechnological lab for bioinformatics. Okay, so types of devices, digital cameras, medical imaging devices, remote sensing satellites, etc. So pre-processing, noise reduction. So these so uh, you need to remove the noise. Actually the image has become ulta here. The B is A and A is B. So just you have to understand that. Okay. So techniques to remove unwanted disorders, construct and contrast enhancement method to improve the visibility of the details and normalization, adjusting the pixel intensity values. You can see that here there is some noise coming here. This part, that is extra colors are given here. And here you can see it is complete image is proper. So these are all the noise which is coming here. Even this part is not properly understood. Here it is properly understood. So that is actually it has become reverse. So just I am telling you, you can understand this. Because by seeing it, you can understand that which is the original image and which is the pre-processed one. This never, it cannot be a pre-processed one. This is the pre-processed one. So anyway, that is why it is given to you in this manner, so that you can have a distinction that this is actually, it is actually a reverse. So before and after pre-processing, it is like after and before pre-processing. Just you should understand this. Means whenever you are seeing an image, you should be in a position to understand that which is a processed image and which is the non-processed image. You can see here, this is correct, the image enhancement. So suppose you are seeing any advertisement of the beauty creams and all, remember that it is not the working of the beauty cream, rather it is the working of the image enhancement. Okay, so after applying the beauty cream, the person is becoming fair. It is never don't think it is like that, just it is this work. Okay, so main point in telling is that it improves the appearance of an image. Okay, it has, you can see it has become very sharp. This is a bit blurred, this has become very sharp. So you can see here, this is an old image, and this is after processing. You can see how nicely it is looking. Even this one, after process, it is looking like this. So these all things you can do it. Image restoration, improving image quality by reversing the known distortions, deblurring, correcting the geometric distortions, etc., etc. Color preprocessing, manipulating and analyzing the color images, color space translations, color correlation, and color enhancement. So image segmentation, this is the image segmentation actually. Partitioning an image into the segments or regions. Actually, methods, thresholding, edge direction, etc. So here this is the grayscale as well as this one, segmentation. Even here also. Just I can say that you can tell that this is the grayscale, but this is segmentation. You can understand the difference between segmentation and grayscales. Then you have the feature extraction. So identify the specific characteristics within an image. Example, edges, corners, texture, space, etc. Shala. Okay. So image compression, reducing the data required to represent an image. The techniques like JPG, PNG, etc. Image reconstruction. So you can see that this is a bit blurred image and this is the sharpened image. So many different things you can do in the image processing. Applications, as already I was telling, many nice. First is, you can see medical imaging, enhancing and analyzing the medical images. Example, X-rays, MRIs for the diagnostic and treatment planning. Remote sensing, analyzing satellites or aerial images for environmental monitoring, urban planning and agriculture. Computer vision, enabling machines to interpret and make decisions based on the visual data for the applications like autonomous vehicles, facial recognition, etc. And also in the robotics. In multimedia, you can do with enhancing the compressed images and videos for entertainment and communication purposes. In forensics, analyzing the images for the evidence in the criminal investigations. Tools, as you already were studying, you have popular image processing softwares which include the MATLAB, Adobe Photoshop, open source libraries like the OpenCV, SCI-Kit, even TensorFlow, even the PyCharm and all, PyTorch, you can use it. Common algorithms include the Fourier transform, wavelet transformation, and various machine learning techniques for image analysis and recognitions. So examples like image acquisition, restoration, image enhancement, segmentation, and then like extraction and recognition. And also you can use like image compression, image encryption. So many things you can do it. Future trends integration with AI and machine learning, enhanced capabilities in image recognition, classification, and predictive analytics. Real-time processing, it improved algorithms and hardware and advancement are making real-time image processing feasible. They are crucial for the application like autonomous driving, real-time surveillance, and in high resolutions and 3D imaging. Advances in the imagery techniques are enabled more detailed and the three-dimensional image processing and enhanced user applications. You have the development of the more user-friendly software and mobile applications for everyday image processing needs. Okay. So let's go the codes now. So everybody, please open the Colab. Please open the Colab. I will be sending you the image for your reference in the chat box. So image is shared in the chat box. Please have a look. So you need to upload. I hope my screen is visible to all.
Yes, sir.
Okay. So here you need to upload. Use this up arrow option, and you can see where your file is. So like this one is the image, and just you open it, and it will get uploaded here. And remember to change the name. There is an option for rename. Okay, please rename it. I will just show you for your reference. So once it is getting uploaded, so you need to either you can rename this or you can use the same name in your code. I hope it is clear with all. I hope it is clear with all. Okay.
Yes, sir.
So first is that you need to import CV2. So I am sharing the code in the chat box. So since you are using the Google Colab, you need to write this because some of the commands of CV2 will not work in Google Colab. So that is why you need to separately write this from the Google Colab patches, import CV2. So import the correct function to display the images in Colab. Okay, this remember that this code may not be used in other platforms like PyCharm and other Visual Code Studio. This is specific for the Google Colab. Okay. Then to read the image from the disk, we use this CV2. So here is the input, CV2 image read, and then you are giving the proper color. So you are giving the proper color for this for visualization. So it is image to color then actually this is the output CV2 image show image. So these two commands will not work in Colab if at all you are not writing this one. Remember it. Okay. So once you are doing it, you will be getting this image. If all the commands are right, you will be getting this image. And remember, CV2 image read is actually for the RGB. Okay, remember it. Okay, now you will be seeing the BGR image. In this also, this is needed. Okay, because already it is there in your notebook. It is not needed. Otherwise, this is also needed. It will not work otherwise. Okay, so next time you will be getting this BGR image. This is RGB, this is BGR. Any doubt so far? Any doubt so far?
No, sir.
Okay. So, you will be wondering that what is the difference. Here this is the taking the image, original image, it should be in the BGR. And here it is actually converting. Okay. The color it is getting converted. Okay. So here we are utilizing the same image in the BGR. It is converted into RGB. Okay. So here you are converting the BGR to RGB. This is the command actually. CV2 convert color. I already told that this is the function for the converting the color either from RGB to BGR and vice versa. So here you can even do that RGB to BGR. That is also possible. Okay. So again, you are getting this RGB. So now you can convert the image into the grayscale. Anyway, CV2 will be there. Just this is used on the path. So here the command is, just check it out. IMG CV2 image read path, CV2 image read grayscale. Here you are giving the directly the command for the grayscale. So it will automatically convert it in the grayscale. Whatever the image is there, it will be read as grayscale. So here you are displaying the image, CV2 image show image, and you are giving the weight key. Why weight key you are giving? Sometimes what happens that if at all by mistake you are typing the run key twice in and then the image will get disappeared. It will not wait. So that is why you are giving the weight key. I have given the weight keys function in the beginning. Here it is there. To hold the window on the screen, we use the CV to wait key method. So since it would be a positive integer, if the zero passant parameter, it will hold the screen until the user close it. Okay. So you have manipulate the image on the color basis, and you are getting the grayscales. So any doubts anybody is having? So you manipulate the image, you will be, and here anyway this is just a picture, so no need to get the ROI and all, because I am not using any this one medical images. It will really take some time if at all you need to detect the ROI. Okay, but this is the usual techniques for the image processing. Okay, any doubts anybody is having? You can unmute and speak.
No, sir.
Any doubt anybody is having, you can unmute and speak. Any doubts?
No, sir.
Okay. If there are no doubts, we would like to conclude the session for today, as well as we want to conclude our workshop. So in the subsequent days, within a day or two, you will be getting the certificates. Anusha, you want to take over?
Yes, sir. Participants, please fill in the feedback form. I have just posted in the chat box. As we conclude our workshop, I want to extend my heartfelt thanks to all our participants and our speaker, Dr. Preenan Bakchi sir, for making this workshop a successful and enriching experience knowledge-wise. Thank you everyone for your engagement throughout this session. Stay connected with us for future learning opportunities. And thank you once again for joining us.
Thank you.
Okay, thank you so much, Anusha. If there is any queries or doubts, you can always reach to us directly. Okay, so we are ending this workshop as well as this particular session. Good night, everybody. Good night.